Okay, so this is going to be a review of radicals. You should know this from prior math experience, but just in case you don't, we're going to look at simplification, addition, subtraction, and multiplication. Did I say simplification? Multiplication. Multiplication first. So the multiplication property says that if I have a radical of some value a, and I multiply it times a radical of some value b, then I get a radical of the product, a times b. This comes in handy when we're simplifying radicals, because then we can break up something that's underneath the radical into pieces and handle them separately. Like the square root of 63. We can break that up into factors of 63, like square root of 9 times the square root of 7, and then we can tackle the perfect square of the square root of 9, take that out of the radical and make that 3 radical 7. Okay, so that becomes a little handy thing. We also have what's called the division property, and the division property says if I have the square root of some value a, and then I divide that by the square root of some value b, then the result is the square root of the quotient of a divided by b. So sometimes it's helpful for us to take this and put it into a fraction like this, or sometimes it's helpful for us to go the other direction. So I'll give you an example of a couple of different things where this would be helpful. We may have something like the square root of, let's say 2 divided by the square root of 8. Well, that could be written as a square root of 2 over 8. Well, we know that that could be written as a square root of 1/4. And now we can take it back to the square root of 1 divided by the square root of 4, and we know that this is 1 over 2. So that shows you actually going from this to this and then back again. Okay, so when we're talking about simplifying a radical, there's a couple of things that we want not to appear. We don't want to see any factors under the radical. Under the radical. Should not be perfect squares. So anytime we have a factor that's a perfect square, we need to remove it. And we do that using the method we just talked about above, that multiplication property. So we're going to look at like the square root of 125, the square root of 125. How would we simplify this? Well, we would want to break this into radicals that have a perfect square factor and a non-perfect square factor, if that's possible. We know that 25 is a perfect square factor that is a factor of 125, and 5 is what we multiply that by to get 125. So if we break this into the two pieces, then we can take this part out of the radical, and we would say, well, this is the same as 5 times the square root of 5, and that would be simplified. Notice that under the radical now, there's nothing, no factors that are perfect squares. So what if we had something like this, the square root of 5x times the square root of 10x? Well, neither one of these have factors that are perfect squares, but if I multiply them together, then we have something where there is. So if I multiply these two things together, we end up with the square root of 50x squared. Well, now we've got some things in there that are perfect squares, like, let's think about 50. Again, 25 goes in there. And 25 times 2 is the other factor that goes with 25 to make the 50. This is not a perfect square, this is. And x squared is a perfect square. So this is the radical that contains everything that is factors that are perfect squares, and here's the radical that contains no perfect squares. So now let's take everything that's a perfect square out of the radical, and we end up with 5x times the square root of 2, and that would be our solution. The last example we've got for simplification looks like this. The square root of 150 x cubed, all divided by the square root of 2x. Well, we see that this is a quotient, so let's see what it looks like if we put it all under the radical and it's just a fraction. 150x cubed divided by 2x. Now this looks like there's something we can do something with here. 150 divided by 2, that would be 75, and then we've got x squared. Now we're getting somewhere, and this is already looking so much simpler than our original expression.